In this video, we are going to review exponents. And let's start with the product rule. If you are multiplying and you have the same base, you are allowed to add the exponents. Okay, it's very important that you look to make sure the base is the same and also that you are multiplying. For example, if you had x to the third plus x to the eighth, this does not equal x to the 11th. In fact, you cannot simplify this. So if you're given this with a plus sign or a minus sign in between the two terms, you cannot simplify. Okay. Similarly, if the bases are not the same, if you have, for example, y to the third times x to the eighth, you cannot combine these. So again, this would be a situation where you can't simplify. Another example. Common base, multiplying, keep the base the same, and we add the exponents. Okay. Now, quick note, if you are raising a negative number to the even power, this is going to be the same as 4 to the 8th. Okay, now let's look at a situation where the base is different, we're multiplying, but the exponent is the same. This is a situation where you are allowed to combine. And what you're going to do here is the power rule in in reverse. So you basically pull out the negative 5, and that is the exponent, and these two factors are within the parentheses. Okay, recall, if you have something like this, the power rule applies to both of these factors. So this is going to simplify to 4 to the 6 times 3 to the 6. So again, here's your common exponent, different bases. You put the two bases in parentheses as factors, and then you pull out the common exponent. Okay, so in summary, when you see an expression and you're multiplying, look for sameness, either in the base or the exponent. If you see that, you will be able to combine things. Okay, here's an example. X to the 7th times x to the 4th. Same base, multiply. Keep the base the same, add the exponents. Okay, here we have a situation, different bases, but same exponents. That means you can put x and y in parentheses and pull out the exponent. And the power rule will apply to both of these factors and give you x to the 4th, y to the 4th, which is what you start out with. Look for sameness. Okay. Let's move on to when you have a situation like this. Different bases, different exponents. There is no sameness here. Therefore, you cannot combine these simply. You can't do something like 12 to the 17th. That is not true. Okay, what you'd have to do is expand these separately. So whatever 3 to the 8th and 4 to the 9th combine to, then you would have to multiply them. There's no simple way to combine that scenario. Okay, remember, Like terms can be added, but if they're not like terms, they cannot. So to simplify this, the only like terms we have here are 2x to the thirds and 1x to the third. So 1 of something plus 2 of that same something is going to simplify to 3 of that something. You cannot add the x to the fourth or the y to the fourth to this entity because they are different terms. It's like having 1 cinder block plus 2 cinder blocks plus something else plus a third something. Okay, these are different. These are the same. So you can combine these to have 3 cinder blocks plus whatever this object is plus the star. Let's talk about negative issues and exponents. If you expand this out and use your intuition, this is negative 3 multiplied by itself twice, and that would be positive 9. That is different than this scenario. These are not the same because of the parentheses. What you have here is you have a hidden 1 times 3 squared, and now PEMDAS applies. Meaning you have multiplication going on and you have an exponent going on. In that case, exponent comes before multiplication. So therefore, we first perform this operation, and we have negative 1 times 9, and that would be negative 9. So notice, these are not the same. It's important to remember that multiplication is commutative. I believe this is how you spell it. Meaning, you could switch factors. Okay, remember, factors are 2 numbers being multiplied together. Terms are 2 numbers being added or subtracted. Commutative applies to multiplication. Therefore, you can feel free to move things around, switch the order of things, if in fact it's helpful to you. For example, if you're given something like this, don't hesitate to rearrange this. Okay, you're allowed to put the 5 and the 3 together. You're allowed to put the x to the 4th and the x to the 6th together. The y squared and the y to the 9th together. This may help you combine things. 5 times 3 is 15. Here you have a common base. Remember the sameness rule. If you have something that's the same, whether it's the exponent or the base, you can do something. Here we're multiplying, therefore we are going to add the exponents and keep the base the same for both the x and the y situations. Okay, let's talk about the 0 power. Remember, anything to the 0 power is 1. You could have some fancy term here. Doesn't matter. If it's raised to the 0 power, it is 1. Something like this. Okay, we have, again, multiplication going on and an exponent. PEMDAS. You do the exponent first. X to the first is 1. Negative 4 times 1 is going to equal negative 4. That is different than something like this. Now the entire function in this parentheses is being raised to the 0 power, therefore this is 1. Okay, let's talk about the quotient rule. There's 2 ways to handle this. When you have the same base in a division situation or a fraction situation, you keep the base the same and you subtract the exponent. If you have common bases in a division situation, you keep the base the same and you subtract the exponents. So be very careful with your negatives. So this becomes y to the 9th. Now there's another way to do this. Namely, take advantage of cross the line and change the sign. So if you have x to the 5th over x squared, another way to handle this is to cross the line and change the sign. So you could throw that x squared, which was in the denominator, as positive 2 to negative 2. Now you have a multiplication situation, and you add exponents when you are multiplying. How about this one? Two ways to handle this. Keep the base the same and subtract the exponents. Or take advantage of cross the line, change the sign. So you could change this to x squared times x to the negative 1st times y to the 5th times y to the negative 3rd. So look what happened here. We took this x to the 1st power in the denominator, it's positive. We crossed the line and we changed the sign to negative. We took this y to the 3rd, which had a positive 3 in the denominator. We crossed the line and that became negative 3. Now, instead of a division situation, we have a multiplication situation. And in multiplication, we keep the bases the same as long as we're multiplying and you have a common base. You add the exponents and you get indeed the same answer. Okay, let's move on to something called the power rule. Very important. The power rule literally means you have something raised to a power, and then you take that something and you raise it to another power. So if you have x to the 5th power, you're raising it to another power. The power rule applies to this scenario. And what you do is you multiply. So this becomes x to the 15th. Now remember what we spoke about earlier. Multiplication is commutative. Therefore, this is no different than x to the 3rd raised to the 5th power. You are going to get the same answer. And sometimes it helps you to change this into x to the 3rd. And you'll see that as we move through examples. Now it's important with the power rule to make sure you apply it to everything that's in the parentheses. So if you have something like this, remember there's a hidden 1 here with the 2. So both of these entities have an exponent. Anything within parentheses, anything you could think of has a hidden exponent or an obvious exponent. Okay, if it's not there and you want to, you could put the 1 there. Anything, it could be a constant. This still has an exponent, and you will apply multiplication and you get 7 to the 4th. Okay, so let's go back to the first term that I had here. Okay, power rule applies. You have 2 factors in a parentheses, both with exponents. You have to make sure you apply the exponent that's outside to both of the exponents on the inside. sorry. Okay, so 3 times 1 is 3. 3 times 3 is 9. You have to do both of them, and then you can simplify this to 8. Similar, here's another example. Okay, you have an exponent raised to another exponent. A power raised to another power. Power rule. Does the 6 have an exponent? Yes, there's a hidden 1. This becomes 6 squared x to the 6th, and you can simplify to 36x to the 6th. Now, just as I mentioned, it's important to apply this exponent to both entities within the parentheses. It's also important to apply the power rule when you have a fraction to both the numerator and denominator. So here's a fraction, and we're raising things to a power. Does that y have a power? Yes, y to the first. So it's important that you remember you apply this exponent on the outside to both the numerator and the denominator. And sometimes you'll have a combination situation. What do I mean by that? That means when you have a numerator with 2 factors and a denominator with 2 factors or more. Okay? So here you have to make sure you apply this exponent to both of these factors. And importantly, you have to make sure you apply it to both factors in the denominator, excuse me. So you're going to end up having 2 to the third x to the third over 3 to the third y to the 6th. And then you could simplify this to okay. Can't simplify this any further because the 8 and the 27 don't have any common factors, and the x to the third and y to the 6th are different bases, so you can't do anything here. Okay, let's talk about negative exponents vis-a-vis the power rule. You're given something like this. And the exponent on the outside is negative. This is how you handle this. You take the reciprocal of what's in the parentheses. Okay, you flip what's inside the parentheses. Two, you change, this means change in math and in physics. Delta means change. You change the outside exponent to positive, and you 3 apply the power rule. Okay, so if you want, you should pause the video and take a photograph of that. Okay, so let's do it in step form. Number 1, we flip what's inside. So we take this, instead of x squared over y, we have y over x squared. We change this power, which initially started as negative 3, to positive 3, and then we apply the power rule. Okay, and make sure we apply it to both the numerator and the denominator. If there were other factors in here, we would make sure we applied it there as well. Let's do another example. What is Okay, what are our steps? The first thing we do is we take the reciprocal of this. Okay, we don't think about anything else. We take this exact expression here and we put that in the denominator. Same sign, we don't flip the sign of the -2. Cross the line, flip the sign only applies to the exponent situation, not an integer. Okay, that stays the same. Now, after we flipped what's inside, we change the sign to positive, and now we simply apply the power rule. Making sure we apply that +2 to every entity involved, every term involved. Okay, if we wanted to rewrite this, simplify that, for whatever reason, we can do y to the 8th over 4 and x to the -4 up top. We cross the line and we change the sign to -4. We cannot take the 4 up here and change it to -4. That is not legal. Okay, you have to keep that +4 on the bottom. Okay, let's do some examples now that we have the basics. Okay, you have 3 times 4 to the 3rd. You have different bases. If you put the hidden 1, different exponents. There's no sameness here. Therefore, you cannot combine these and do something fancy. Okay, you can't say this is 12 to the 4th. What you basically have to do is expand these out. 16 times 4 is 64, so you have 3 times 64 equals 192. Okay, there's no way to combine those because there's no sameness. Exponents are different, bases are different. Okay, situation. If it's easier for you, you can move these around with impunity. What I just did was legal because multiplication is commutative. Common base, multiplying, add the exponents. Okay, 2 ways to do this. Take them one at a time. You can say this is x 5 minus 1, y 6 minus 2, x to the 4th, y to the 4th. Or you can use cross the line, change the sign. Now you have a multiplication situation. So you add these exponents. Keep the base the same, add the exponents. Base the same, add the exponents. Cross the line, change the sign. Okay, this situation. You have 7 to the -2. Okay, you can put a parenthesis around this. Change this to 7 over 1 to the -2. What do we do when we have a power situation? Because these all both have exponents and you have a negative exponent on the outside. We take the reciprocal. So 7 over 1 becomes 1 over 7. And we apply the power rule after we change it to a positive. So now you have 1 squared over 7 squared. 1 to any power is always 1. Now you have 1 over 49 as your final. Cross the line, change the sign. How about this one? Power rule. Got to make sure you apply this to all the exponents, all the factors. So now this is going to be 4 to the third, because that 4 has a hidden 1. You're multiplying 1 by 3. X to the 12th, y to the negative 12th. If you want to clean this up a little bit, what did I do? I took this y to the negative 12th, which was in the numerator, and I threw it into the denominator. In doing so, I crossed the line and I changed the sign. Don't be confused if they throw different variables at you. Okay, the fact that those are j's, don't let that fool you. If you want, change it to x. Okay, what's going on? Common base. Multiply. Keep the base the same and add the exponents. So this is going to be x to the negative third, and you can change that to j to the negative third. This is j to the negative third over 1. We could change that to 1 over j to the positive 3. We took this, we crossed the line, we changed the sign. Okay, that's enough for this video.